without wasting time, a brief introduction of the topic and yourself, and then we will be starting. Is it all right?
Sure, let's go for it.
Well, awesome. So, welcome everyone. Welcome to today's webinar by our own Scott Ambler from Canada. Scott Ambler is the consulting methodologist with the Ambysoft Inc, leading the evolution of Agile data and Agile modeling methods. Scott is an international keynote speaker and the co-author of 30 books. Rest of the introduction Scott can give by himself, but today he is going to talk about artificial intelligence for project managers. Are you ready?
I am. Yeah, if everybody could go on mute, that would be good.
Yeah, yeah, uh, yeah, that would be the case. Okay, handing over to Scott now. Thank you, Scott.
Okay, thank you.
Yeah.
Hi. Well, thanks everybody for your patience. I guess we had some technical challenges earlier, but I'll get going here. So, anyways, so as you heard, I'd like to do a brief walkthrough of AI for project managers, and particularly how does this AI stuff work from the point of view of if you're leading an initiative, an AI initiative. So my name is Scott Ambler. I was a vice president at PMI for a little over 3 years, I guess. I'm also one of the co-creators of the Discipline Agile Toolkit being offered by PMI. I am a consulting methodologist and Agile data strategist with Ambysoft, my company based in Toronto. And I'm the thought leader behind the Agile data and Agile modeling methods from about 20 years ago now, but they're still very solid. And in particular, the Agile data material is absolutely critical for your success at AI from the looks of it. So this is very good for me. So anyways, what do I want to walk through? I'm going to do a very brief overview of AI and a little bit of overview of terminology. Then I'm going to walk into the life cycles or the life cycle of a AI machine learning initiative, and basically explain how it works from end to end, and then of course back again, because there's feedback cycles, as you would imagine. I'll get a little bit into the data quality challenges that most organizations face. This is a very serious problem that we need to finally take seriously. So AI has sort of brought this to a head. And then I'll walk through the success and failure factors surrounding AI. So what isn't AI? So first of all, or what is and what isn't AI? It's not magic. I'm actually, I went back after leaving PMI. I went back to school and I'm working on a master's in artificial intelligence. I'm roughly halfway through at the present moment, so I'm aiming to end by Christmas of 2024. And so one of the things I've very clearly learned pretty quickly was that there's no magic. It's just a lot of very hard work going on. So let's walk through a few definitions. So first is deep learning. And deep learning is one style of AI where the technology sort of looks like neurons. It's a collection of interconnected neurons, and they're basically mathematical functions when they get down to it. So it's not really neurons, but it's metaphorically neurons, I guess we'd say. Machine learning, which is what I'm going to focus on here, and the reason why I'm focusing on machine learning is because this is what most organizations will be doing when it comes to AI, if you're developing your own organizational AIs. So this is the ability of the AIs to learn without being explicitly programmed. So you're not writing a big pile of code. You're actually more than likely leveraging existing algorithms, although if you're very advanced, you might be tweaking some existing algorithms, but feeding them a lot of data and then training your own models based on the data that you curate. And this is where the data challenge comes in. And then finally, AI is computer systems that appear to be intelligent. And we're seeing ChatGPT and DALL-E and Midjourney and all these very interesting generative AIs that are they're really sort of cool. but they're not intelligent, and we're nowhere near intelligent systems, regardless of some of the hype that we're hearing. We're getting close. We don't quite know when, big arguments over when that's going to happen, but certainly not right now. So right now, we're just probably a little bit beyond this. We're still with, working with Annie's artificial narrow intelligence. Although the GPT class of technology now has gone a little beyond that, but still not that much. Enough to be very interesting, but not enough to get us to here. And this is where we see AIs that are smart, or more than likely smarter than humans, with a wider range of abilities. Right now, the AIs are still pretty narrow. ChatGPT chats. DALL-E, it produces images, and so on. So they're all very still narrow AIs. And this is a bit scary. This is where we've got to start really worrying about AI's potential taking our jobs and not just augmenting us in our work. And then where we're in serious trouble is when the AIs become super intelligent, and this is what we're really afraid of. I highly suspect that ASI will follow very quickly after AGI. These sorts of technologies tend to follow a hockey stick graph, where they go along very flat for a long time, and then boom, they improve dramatically very quickly, which is what we've seen with GPT. For example, it's taken off in the last year or so because it finally hit that boom point, the hockey stick point. So some other terminology, and these slides are on slideshare.net, a slightly older version of the slides, but still content's like 99% accurate. They're available on SlideShare if you're looking for this. I might throw some of this terminology here around. I'll probably talk about data labeling. That's about it. But anyways, I just want to make sure you have this terminology just in case. One of the big challenges with AI is that it is complex. It's technically complex. It's logically complex. And it's really, really hard to come up to speed on what's going on. And frankly, I'm not sure anybody knows completely what's going on. It's moving so fast now, but it does take years to really learn this stuff. If everybody could go on mute, that would be great. Okay, so are you ready for AI? The answer is probably no. You're probably not there yet for several reasons, which I'm going to walk through. And it's at the organizational level. Might be different for you at your personal level. So does your leadership understand AI? Oh, and I should point out, if the answer to any of these questions is no, then you're not ready. They're all pretty much showstoppers. Does your organization have a clear AI strategy? And to be fair, you might be working on this, so I'll maybe give you credit for that one. Do you have AI expertise available, including data scientists? You need a lot of you need a lot of very skilled people to pull this AI stuff off. Can you staff teams with dedicated, diverse, and interdisciplinary people? So not only do you need very technically able people, they should hopefully be dedicated to the initiative. None of this, 50% on this and 50% on that and 50% on this third thing. None of that nonsense, but 100% dedicated to this initiative. And are they, do they have diversity? And are they cognitively diverse, culturally diverse, and so on? So, and the reason why is due to bias. And the biases in your data, the biases in your process, and you do have bias. I'll talk about bias a bit, and you will always have bias. There's you can reduce it, you can't eliminate it. At least it hasn't been done yet. Do you understand your current level of data technical debt? And even more harsh, do you even know what data technical debt is? Sometimes called data debt. So if you've heard of that, then I'll give you credit as well. But anyways, do you actually understand it? Do you measure it? Do you understand where your challenges are? And the reason why I'm asking this is I've been involved with a few what was hopefully going to be short 6-month AI pilot projects, and they turned into what is very likely going to be multi-year data fixing projects. And it's because of the data debt that these organizations had. And I'll talk about this in detail in a bit. And finally, do you have a realistic vision for what you want to achieve? You as an organization, for what you want to achieve with AI. And when I say realistic, I mean, do you understand all these other things? Do you actually understand what you need to do to pull it off? And are you going to be able to stick with it when things don't go well? AI efforts, initiatives, projects, whatever you want to call them. I'm going to argue in a bit that these are not projects, but anyways, these AI initiatives have a very low success rate for many reasons. But you need to go in eyes wide open on that. Expect to fail because just it is what it is. So let's get into the machine learning lifecycle. How do you actually pull these efforts off? And I should point out, you're going to want a discipline hybrid strategy. So PMI's Discipline Agile Toolkit is a very good start at understanding what you're going to need to do to pull this off. And I'll walk you through this in a minute. So I'm going to start this section with what I believe will probably be 4 uncomfortable observations. At least 1 or 2 of them will be uncomfortable, and then a claim, all of which I'll back up. I wouldn't bring any of these issues up if I couldn't completely and utterly justify them. So first, this is not a project. And I appreciate there's a lot of project managers on the call, given that it's the PMI chapter, but this is not a project. And if you try to treat this as a project or a series of maybe a series of projects, all you're going to do is inject a lot of cost and risk and time into your initiative. And I appreciate that many of you probably work in organizations where everything gets funded in terms of projects. Okay, it is what it is, but understand that this is not the way to go, and that you'll very quickly discover, and I'm going to walk you through why in a few minutes, why this is not a project. So you're going to learn this the hard way. And if you try to shoehorn this into a series of projects, well, it's going to go poorly. A predictive approach, the traditional waterfall, serial approach, whatever it is you want to call it, has exactly 0 chance of success at AI. I'll walk you through why. It's just the nature of the beast. Predictive approaches to software in general have phenomenally low chance of success these days, but certainly for AI. A pure Agile approach, so if you think Scrum is going to get the job done, has very little chance of success as well, because of a lot of the purism, shall we say, and zealotry in that community will blind them to what they need to do. And you'll see this in the life cycles in a second. A pure lean approach has a better chance of success, but still isn't ideal. And what you really need is a hybrid approach of all 3, mostly lean, but some agile and a little bit of predictive to get the job done. And this is exactly the type of approach that you see in Disciplined Agile, for those of you who are up to speed on that. So my claim here, and like I said, I'm going to justify this, is that a disciplined hybrid strategy, and Disciplined Agile, the Disciplined Agile Toolkit is a hybrid. It's misnamed in many ways. It started Agile, but it's misnamed. It really is a hybrid. And so a disciplined hybrid strategy will provide your highest chance of success. And understand going in that, as I said earlier, AI initiatives tend to have a low success rate, and some of it is because teams make some of these mistakes that are implied on this slide. So let's take a really high level view of the machine learning lifecycle. One of the things, as I said, I'm working on a master's degree in this, and I've been sort of shocked that there isn't very good descriptions, at least at a high level, of how this stuff works. And typically the description that you'll see is that, we build the AI, we train the model, and then we release it and we operate the AI. It makes inferences. And usually the terms are, training the model and then making inferences. And then of course there's feedback going back, and there's learnings, and we retrain the AI because we learn stuff, and then we re-release it. So this quick life cycle here. Oh, and by the way, if you look at actual AI models in production, like out there in the wild, some of them are being updated every few minutes. I don't know the exact update rate of Netflix, but I know it's got to be at least daily. It's probably more often than that. It's probably on the order of minutes that they release updates to models, but it's got to be at least daily, because they're releasing new new shows into their environment on a very regular basis. They're taking shows away on a very regular basis, and the AI needs to know about this, right? You don't want your AI engine recommending things that you've removed from from your database, nor do you want it ignoring things that you're trying to promote. So you've got to be updating constantly. And of course, you've got new users, and the users' preferences change over time, and I'll make different decisions when I'm watching stuff and so on. So the AI needs to be learning constantly. So we're going to be retraining that AI constantly. Other AIs, insurance AIs, I worked on an insurance fraud detection a while back. Those things can be, maybe released monthly or quarterly, even depending on, the type of insurance in the market and all that good sort of stuff. But it's still being released on a fairly regular basis. So right away, this pretty much kills off the predictive approach. It also pretty much kills off projects. The idea of treating this as a project. If you're going to have to, if you're going to have to update and release your system, your AI, your model, on a weekly basis, a daily basis, an hourly basis, quarterly basis, whatever, it's clearly not a project. It can't be. You're in product land now. So this is a challenge. So let's add some detail. So let's flesh out what do you actually do in construction. Well, you've got to choose a training strategy. There's many different algorithms that you can choose. There's many different categories of problem. So are we trying to classify things? Are we trying to predict values? So, what type of prediction are we trying to make? Basically, are we looking at pictures and say, oh, that's a cat, or that's a dog? Are we doing that sort of a thing? Are we classifying what's in that image, or are we trying to predict the value of a stock 3 hours from now because we want to make some money? So what are we trying to do? So depending on the nature of the problem, you'll choose a different type of algorithm, or perhaps collection of algorithms, because your model might be a collection of models and their answers are being averaged out and combined somehow. Then you're doing preparation of the data. You got to do a lot of data cleansing and a lot of data selection. And this is a bit problematic. I'll talk about that in a bit. And train the model. Then you got to test, you got to validate, and you've got to deploy the model. Now, usually what happens is, the first 4 bubbles are what most of the literature focuses on, because it's hard. Particularly the training stuff and it's all hard, but anyways, all technically challenging, shall we say. So this looks predictive, but it really isn't, because when you look at what happens in reality, those 3 middle steps are very iterative in nature, right? So we fix some data, train the model, we realize we got to fix something else, or unfix something, as the case may be, and so on. Our requirements evolve as well over time, because our stakeholders are not good at telling us what they want. They probably don't have a handle on what they can actually do and not do, and so we're learning as we go, and that's okay. So very agile in that way. And there might, arguably there's a line missing here. Every so often, things go so poorly that you need to rethink your strategy again. But let's assume things are going reasonably well, and your validation is a back and forth. It's not a testing phase. This is an ongoing testing activity. You'll be testing constantly. Particularly later on, like a few weeks into construction or a few days into construction, as the case may be. You'll eventually also have to deploy the AI. Now, ideally, if you have a full DevOps and a full data DevOps pipeline in place, and you have experience deploying AIs, then this is probably a fully automated activity. For those of you familiar with continuous integration and continuous deployment, you should fully automate this. If this is new to you, then this deployment effort could actually be, particularly the first time you do it, could actually be several days or several weeks, just depending. Particularly if things go poorly, it tends to be longer rather than shorter. Stuff happens, right? But anyways, deployment is a bit underappreciated, although I think it's getting now with more people doing AI, it's becoming a bigger and bigger thing to talk about. Some of the big issues are, how many versions of the model do you have to deploy? So, for example, if you're in insurance, the Auckland market is very different than the Toronto market. So, if you're an international insurance organization selling car insurance, perhaps in multiple cities around the world, you might have a model for each major city or each major metropolitan area. Just because the nature of the driving and the culture and the rules and all that sort of stuff are different. It is what it is. And so you'll have different models reflecting these different markets. Other issues are, where are you actually deploying to? Are you deploying into the cloud? Are you deploying into edge devices like phones? And these are serious challenges. Recently, in the last couple of years, it's been viable to deploy AIs to edge devices like phones. And the AI is pretty much running on your device and not hitting the cloud for cycles, and that's critical. And of course, it makes inferences, and there's a learning learning feedback there. So that's a good start at a life cycle, but it's still not complete. You'll probably notice a big white space on the left-hand side. And what's missing here is some sort of an inception phase or an envisioning effort. Do you actually know what you want to achieve with this AI? What are, you don't just jump into building, oh, let's just build an AI and, we'll get going on it this afternoon because, we got nothing better to do. You got to do a little bit of upfront thinking. You got to start putting your team together. You got to, all the, inception phase stuff that occurs in that, Discipline Agile calls out explicitly. And that, some of your agilists, particularly the purists, tend to struggle with as a concept. Now, you've got other challenges here, though. So, for example, so you see there's three main bubbles there. What you have to explore the usage. What are you trying to achieve with this AI? How are you going to make the world a better place? How are you going to, better serve your customers? How are people going to work with and interact with this AI? A big challenge in the AI community, from my point of view, is that it is incredibly focused on data, and rightfully so. Data is absolutely critical, but that doesn't mean data drives everything. So if you don't understand how your AI is going to be used, it doesn't really matter how good or how bad your data is because you don't know what you're doing, right? So what you're trying to achieve should drive what type of data you need. So you're going to be exploring the usage, and you're going to be exploring the data in parallel to each other, and you need to do a little bit of this up front because you've got to do a reality check. Can you actually build this thing? Does it make sense? Does it make business sense? Is it technically possible? Is another valid question you should be asking. And the usage and the data will have a huge impact on each other. So you'll want to do certain things, but then you won't have the data for it, or you might have the data, but it's of such low quality you can't really do anything with it. So at least not yet until you fixed it. So your data is both a strength and a weakness for your organization, depending on your level of data technical debt. So, anyways, this is a much more realistic version of a life cycle for machine learning. And notice how, even though, excuse my graphical abilities, but this is really an iterative and incremental hybrid life cycle. As you can see, there's some traditional, this concept of phases, for example, is smells of being predictive, but it's really an iterative and incremental thing. If you look at the if you look at the internal workings, it really leans more towards being agile, but you need to keep it lean and efficient and effective and keep the flow going, particularly when you have models in production and you're making inferences. You want to keep them up to date. You want to keep an eye on them as well. This is what validation is absolutely critical for. So I'm sure many of you have heard about Microsoft Tau. It was a chatbot released a few years ago, and they pointed it at some questionable discussion forums, mostly right-wing, online. And within 17 hours, the Tau became a raving racist that was recommending certain groups of people need to be killed and all that good sort of stuff. So they had to pull it from production, for obvious reasons. So anyways, the point is that AI works at the speed of the internet. and you have great ability to dramatically and to very quickly reveal biases and problems, and then exponentially expand on them and make the problem incredibly large and worse. So congratulations to Microsoft for having the courage to pull that model, when they did, as early as they did, and better yet, the competence to keep an eye on it and be able to actually monitor what's going on, because that might have been easier said than done. So some common risks that you might want to be aware of. So here we are, arguably in management land now. So during the envisioning phase, do you have misaligned stakeholders? Do you have data challenges? Do you have data technical debt? How biased is your data? Do you understand the biases in the data, or at least do you sort of have a clue what they might be? And this is why you need a diverse cross-disciplinary team, because you need this diversity to help you detect and then hopefully overcome as best you can these biases. You really want to be asking about the viability of this on a constant basis, just because of the low success rate in this space right now tells you need to be constantly asking, is this viable? And if it's not, either get it on a new path or kill it off, because throwing good money after bad is not the way to go. And then not doing enough initial exploration, or doing too much. I've worked on efforts where the team during envisioning spent months doing envisioning, and frankly went off into design fantasy land. And they had wonderful designs, and it was spun an incredible story, but the effort was taken out and shot because it just wasn't viable. It didn't make any sense. They had a wonderful design. I'll leave it at that. Any great vision, couldn't execute to save their lives. But anyways, during construction, almost always your data technical debt will prove worse than originally believed. You'll probably go in thinking we're in a bit of trouble, but we can overcome it. And then when you start to really dig in, then the horror story starts. This is a fairly normal thing. This is well known. I've been to numerous AI conferences in the last year and a half now, and in hindsight, I really wish I'd kept track of the number of speakers who talked about data debt, and then basically said, and yeah, we need to do something about that. It's really bad, and left it at that. So this is a known problem that not enough effort is being put into understanding. But like I said, I got a little bit of material coming up on that in a minute. Never-ending edge cases gives you an unpredictable timeline. So what I mean by this is, as you're building your model, as you're building your robots, in case you're doing robotics instead of AI, you run into problems, and you run into things that, we just can't figure that out. Or we just can't figure that out now, and it's going to be a little bit of work. So for example, I was working with the robotics firm about a year ago, and they ran into some edge cases. They were, the robot hand was trying to pick things up, and it could pick up boxes, but if it tried to pick up a piece of fruit, it would crush it, and you'd get banana everywhere. So that picking up a banana, that was a 3-month problem that they didn't know they had until they ran into it. And they could very well have had problems picking up coffee mugs or something as well, which they also wouldn't run into until they, tried to pick up a coffee mug and it exploded, or, whatever happens. So anyways, from a project management point of view, this is a bit frustrating because your timeline is going to be effectively hard to predict. Now, in some cases, maybe you can, drop some of these edge cases. So perhaps in this release, we don't have to pick up bananas. We can leave it to release 7. And in some cases, no, we need to be able to pick up bananas. Sorry, figure it out. So anyways, that's a bit of a challenge. When we go to deploy the AI, are stakeholders even prepared to use it? Do they understand the implications? Do they understand what the changes to the business processes and all that good sort of stuff? When we start making inferences, when it's up and running in production, we might have biased usage. We might have biased data, which then things get out of hand. very quickly. We might be using the system in a biased way. So maybe the AI is fairly clean, but we're using it inappropriately. Classic examples of that is facial recognition systems that, they used to pitch these things to, we're going to use this facial recognition system to, hunt down and save children that have been taken. And sure enough, that sort of stuff happens, but they're also, they're also using it to monitor everybody's movements as well. And there's wonderful case studies where that sort of stuff happens. And it's still happening today. Anyways, and then when we're providing feedback into our models to continuously update them, we might have what's called model drift, but more accurately, it's reality drift. And what that means is, so today we're training our model, right? And it's based on the information that we have right now today, but then we release it in production and it's making inferences. And the longer we go to update the model, the more and more reality is changing, right? Our business environment changes, the environment changes. So in the case of car insurance, maybe there's a catastrophe and half the roads are destroyed, and that has a pretty serious implication to insurance fraud and other things, right? That's a bit ridiculous, but it happens. But more accurately would be Netflix, right? So they train a model today based, and that model knows about whatever shows are currently available in your area today, and then 20 new shows get released 15 minutes later. It doesn't know anything about them, and 15 shows get dropped as well. So now the model is out of sync with reality. Is that so we're blaming the model, but it's really reality. It's the problem child here. So overcoming the data quality challenge. This is a long time coming. And for those of you working in organizations that you've probably already run into this with, if you're in an organization that's been trying to make data-driven decisions the last few years, or you've been doing data warehousing and things have not gone as well as you'd hoped, it's probably because of your data quality problems. Your data technical debt is too high. And so what sort of data quality problems might you be facing? And this is just an exemplar list. This could be 100 things long. But anyway, so things that are sort of semi-unique to machine learning teams, or at least that machine learning teams get hurt by the most. Biased data. There will be bias in your data because your data reflects your business processes. Your business processes reflect the ways of thinking of the people involved, and the people involved have biases. It's just human nature. You might not have enough data, or what's usually the case, you don't have enough data for certain types of situations. So maybe we've got a lot of data for, maybe your insurance company has a lot of data for New Zealand drivers, but you have an influx of Canadians moving to Auckland, and you don't have very little data, if any, about how Canadians drive. Well, that's a pretty serious problem if you're trying to understand how much to charge these people who are new to the New Zealand scene. So anyways, so that happens. There's biases in your data. This lack of Canadianness in your data could be problematic for you. There's semantic differences. There's inconsistent data. You don't really know where the data is coming from. You don't know where to get the data from. This can be a problem. Or you might have 5 different sources. Which is the best source? Or, which sources should you avoid? You might have some significant privacy and security considerations. And luckily, the data laws are improving on that one. Just forcing the issue across the board. Data poisoning. You might have, so when you're training the AIs, or when the AIs are learning because, relearning things because they're in production, you might have people who are purposely putting in data to mess up your AI. Or it could be happening as, it might not be being done on purpose by the people, but other systems or other environments could be putting in inappropriate data, or data that's causing your AI to react improperly, whatever you want to call that. So this is a problem. An interesting challenge right now with ChatGPT is that more and more people are publishing books and web pages and articles with AI generated information in it. So now when the AIs go and take a pass at that data and ingest it into their system to learn, it's learning based on AI stuff. So the data is effectively poisoned with AI generated information. So there's some very, so this is an interesting topic in the AI community right now, if you're into weird topics like that. So some data quality techniques that you might want to be aware of, because the good news is you've got options. So the big elephant, or the most popular technique is data cleansing at the time of usage. So you've got all this poor quality data being ingested by the team. So the team has to do the work to clean the data on the spot. This is sort of the last line of defense. It gets the job done, but it's incredibly expensive. And frankly, it's the last line of defense. There's many other strategies that you should have applied a lot earlier to avoid that problem to begin with. But anyways, there's choices. So here's a few others. You can do AI data cleansing. So instead of having people doing the data cleansing, you could have AIs. There's AI tools now, fairly good to do this sort of stuff. Database refactoring, fix the data at the source. That's the real solution, by the way. Stop putting band-aids on all your data quality problems. Automated regression testing. Do you have automated tests for your data sources? Data is the lifeblood of your organization, and yet more than likely you don't have a regression test suite for it. Shame on you. Shame on you. And then you're wondering why you got so many problems. You're not testing properly, and you got data quality problems. You might want to put 2 and 2 together. Creating synthetic training data. So when you're missing that Canadian data from your insurance database, you create fake Canadian data to train, and hopefully do the best. Do you have data architecture? Are you transforming the data, or before it gets to the machine learning team and so on? So the point is that there's many different techniques that you can be using, and then what you want to do is learn how to use them. Choose the right ones for the situation that you face. This is actually something that I've got a detailed article on at the Agile Data site, by the way, and I think I've got a reference coming up for this too. So the good news is that there's opportunities to actually address the data quality problems. So some ethical considerations that you want to be aware of. Now, I'm not in a position to lay down the law regarding ethics. Frankly, nobody is. This is something that your organization needs to make decisions on themselves. I'm going to make some suggestions of what you want to think about, but I'm not going to tell you, I'm not going to define ethics for you. There's many people working on this. There's a lot of great material out there, but at the end of the day, this is a decision that your organization needs to make. So an Auckland-based insurance company will have a different set of ethics than a Toronto-based insurance company, because they're working in different environments and different cultures and all this sort of stuff. There'll be great overlap. I have no doubt about that. But there'll still be differences, and those differences will be important. So the Google ethics and the Meta ethics and all that good sort of stuff. And the IBM's got a set of ethics. Great stuff to look at and get ideas from, but you're still going to need to work it yourself. So anyway, so here's a few things I would consider minimal things to be thinking about. So safety, have you worked through the potential harm that you may be doing with this system, this model that you're building? And this could be physical harm, it could be mental harm, financial harm. There's a great book called Weapons of Math Destruction. Was written a few years ago. The name of the author is not coming to me at the present moment, but her book is incredible. It's just basically a collection of case studies of sometimes artificial intelligence, very often just data inappropriate uses of data, and they've discovered after the fact the harm that was being caused. People were being thrown in jail, being denied medical treatment, and being denied loans because of poor quality data, because of the bias in the data, basically. So there's safety considerations. Human dignity. Do you understand the overall process? Are you taking societal values into account? There is a huge opportunity to put a lot of people out of work. And yes, you're being competitive and blah blah blah. There's lots of good excuses, but at the end of the day, and it might not be your staff that you're putting out of work. What happens if you're taking, you're destroying if you're out competing one of your competitors, or one or more of your competitors, and you're putting them out of business? So there's some very interesting issues here. Fairness. Have you considered bias in the development of your model? Are you actively looking for bias? Have you built a team that can do this and is aware of this? And are they empowered? Is it psychologically safe for them to point out that maybe you're building something that's not fair, and have business processes that have been going on for decades, perhaps, that are clearly not fair? This is hard. Accountable. So if the AI makes a decision, who gets held responsible for it? If you're building cars, for example, like self-driving cars, and the car kills somebody, and they will, guaranteed, and it has happened, so that's easy to predict, but it will happen again. Who's accountable? And the interesting thing is the self-driving cars are far safer than human-driven cars. But everybody's afraid of cars killing people, and accountability is a big issue there. Who are you going to sue when the car runs somebody over, or the car slams into a rock in order to not run somebody over? These are the types of decisions that the self-driving cars make, and those are the types of decisions that human drivers make. No different. Just the cars are better at it, strangely enough now. And trustworthiness. Do you even understand how the decision got made? This is a very serious problem. Some of these, a lot of these AIs are black boxes. How the heck did it come up with that? There's been instances where some AIs have been trained on to be able to do natural language processing, and they learn in the process of training them, they pick up new languages that they were never trained on. And yet somehow they can read Farsi, for example. I don't know if that's one of the languages they learned themselves, but yeah, and very weird things can happen with some of these AIs, particularly the ones that are the unsupervised learning ones, even the supervised learning ones actually, but certainly the unsupervised ones. So some of the business implications of AI. AI should be forcing you right now to be rethinking everything. There's a lot of great opportunity here, to augment your staff, to increase your efficiency, to improve your decision making, to improve governance. There's so many opportunities to apply AI to improve governance. Just that alone should be of great interest to a lot of organizations, particularly with the new data law, privacy laws, and all that sort of stuff. But there's some huge risks. There's just the opportunity for rapid and dramatic and public failure that Microsoft tout. Microsoft did an incredible job at recovering from that, but that could have gone very poorly very quickly. It'll be interesting to see what Elon Musk's new AI does. Keep an eye on that. I think it'll be entertaining, but who knows? So great opportunity for reputational risk. There's a few other interesting problems. So you'll probably want to interact with some psychologists on this. People tend to trust the AI results far more, or just results coming out of systems far more than they should. They'll trust them over the opinion of a person, for example. So many people have very unrealistic expectations of what AIs can do, and then inappropriately use the outputs. And then, of course, the biased decision making, both of the AI and of the people using the AI. So actually, that book Weapons of Math Destruction has some wonderful examples. Well, not wonderful if you're on the receiving end, but has some very interesting examples of judges using the advice generated by AIs in their decision making as to how long somebody's sentence should be. And some of the judges almost took the advice verbatim, apparently, until they started learning a bit about what was actually going on. So interesting challenges. So be aware of them. Go in eyes wide open. So some success and failure factors of an AI initiative. So earlier I was talking about, is your organization ready? But this is more a question along the lines of, is your team ready? So are you ready for to start up an AI initiative? So do you have realistic, and once again, all of these should be yes, should be answered in the affirmative. So do you have realistic expectations over what you're trying to achieve or what you can achieve? Not what you want to achieve, but what you can achieve. And yeah, you might want to have stretch goals, all good sort of stuff. Do you understand the ethical issues surrounding what it is you're trying to build? Are your leaders, are the team leaders and the people you're reporting to, include on both the technical and business side, are they capable? Do they really understand what the heck is going on? Do they understand the implications of edge cases and of data technical debt and all that good sort of stuff? And are they willing to still proceed? Do they understand the ethics and the privacy issues and all that good sort of stuff? Is your data ready? Or if it's not, are you prepared to get it ready? And fix it at the source. This is something I've been talking about for a long time. Data cleansing, as done by the machine learning community, is a band-aid. It really is. We need to fix the source. If you're fixing it at the last moment, that's a band-aid. That's strategy of last resort. And can you build a diverse cross-disciplinary team of dedicated staff? I would say this of most initiatives, but this is certainly absolutely critical in the AI space. And finally, have you defined your way of working for the initiative? Do you understand that life cycle? Do you understand how you're going to approach, or at least prepared to invest the time to understand how you're going to, when you hit it, when each of these activities in phases and all good sort of stuff. Thinking through deployment long before you go to deploy is a generally good idea. Thinking things through before you start doing is generally a good idea in general. So finally, if you're, I'm happy to do this presentation for other organizations, other groups. So if you happen to be involved with other groups, feel free to reach out. So thank you very much, and hopefully we have some time for questions. I appreciate that we started a bit late today, so things might be a bit hard. But anyways, are there any questions?
Thanks, Scott. And I got one question from Skyvoo. You mentioned some bad decision made because of misuse the data and poor data. How can we avoid that?
Okay, well, yeah, so a lot of it is, so first, if you've got poor data, you need to fix it. AI is a garbage in, garbage out thing, period. So if you've got poor data going in, you're going to have poor results coming out. There's nothing you can do about that other than to fix the data. So you got to have clean input going in. And that might mean you've got to invest time to fix the data. Now, what's interesting, I'm going to beat up the project managers among us. Much of the data quality problems in organizations are the result of poor project management decisions. When you're trying to hit a budget, when you're trying to hit a date and a time, particularly on an IT project, well, what happens? Quality gets short-shrifted, right? It's like, oh, well, we'll fix the problem later, blah, 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 and then later never comes. Well, later now has come now. So it's really sort of so there's a lot of the data quality debt, a lot of the data technical debt is the result of bad management. Now, obviously, it's really the business people that are driving the project managers to make them and force those decisions onto the team, and the team does question things, never get the date. That's what's going on. But still, the on time on budget. But anyways, yeah, you got to fix the data and be aware of the problem, and build diverse teams. That insurance company Auckland that I made up, you would have zero hope of identifying your anti-Canadian bias, unless you get very lucky, or you have to have a Canadian on the team. Wait a minute, you're doing that? Well, there's all these Canadian drivers. That's simply not true of Canadian drivers. You know, those are the sorts of conversations that occur, and you stumble into these biases. Usually because the person that identifies it has been on the receiving end of that bias, and they have a better understanding of what's going on.
So we got few more questions. The next one is, many New Zealand government agencies have implemented a blanket no AI type policy until we know more. What limitations does this style of attitude bring? How do we address this from the coalface?
Yeah, so that's really unfortunate. The Actually, this sort of thing's happening in Canada as well. In Canada, it's a bit different. It's not a no more issue. It's more of a well, what the real issue is in Canada, the government has made a commitment to build unbiased systems because Canada has a very diverse culture, and we grow our population by several 100,000 people every year from all over the world. So so we have to. So anyway, so the Canadian government has decided not to build systems with bias in it, to the best of their ability. And the challenge is all these AIs have bias in them because of the data. Now, frankly, I don't mean to burst anybody's bubble, but because of the biases in the data and the systems, regardless of whether the AIs or not are using this data, those systems also have bias in them. But so anyways, so the Canadian government is sort of fooling itself in that respect. But anyways, so they've decided to be very leery about AI. Now they're still applying it for certain things. We do a lot of climate change, climate systems due to climate change because we're getting hammered just like you guys probably are too. But anyway, so they're doing that there. But so if they're in wait and see mode, that's a bit irresponsible in my mind. I would hope, but what that policy really is that we're not going to deploy things into production until we know more. But part of learning and part of knowing more would be they need to be experimenting now and learning this stuff now and building up skills and knowledge now. And then when it gets a little safer, I suppose, hits whatever levels of safety they need, then they can start deploying. But yeah, if they're backing off of AI, it's not a good idea. Well, it means they'll be behind, right? So, the citizens will suffer for that, but it happens.
Awesome. So we got like two more questions, and they will be last two questions. The next question is from Pradeep Ramakrishnan. Hi, what are the key skills or knowledge areas that project managers need to develop to leverage AI in our role?
So luckily, I don't know if you're aware of this, but PMI has a free online certificate in AI that you can take. It takes 2 or 3 hours. I think you get 5 PDUs for it, but it's probably 3 hours. It's not that long. So it gives an overview, but it goes into the issues, and it talks about how we can use it to do we can use AIs to augment project planning and estimating and this and that and write reports on good stuff, which is all of which is true. It doesn't go into the stuff I was talking about here today, about here's the life cycle, here's what you need to do. I don't know of any good training courses that go into this yet. You can do what I'm doing, go off and get a master's or degree, or some other degree or diploma in this, but it's really technically, I've got a computer science degree and I'm struggling sometimes. So it's a pretty hard thing. It's not geared for managers at all. Now there are some executive programs out there. MIT has one. Maybe the one of the universities in Asia. I would have to think somebody in Asia Pacific's doing this too. But there's short-term executive degrees, online diploma type things as well. But I think it's still early days. And like I said, there's nothing that really goes into the life cycle issues like I have here. So it's either you get some, very, very high level stuff, or you just dive down deep into the nuts and bolts. There's nothing in between right now, from what I can see. So it's a bit of a problem.
Yeah. Thanks. Just last question from Terso Giriyu. Hi Scott, do you think there is a lot of prejudice against AI? Whenever I talk with my academic colleagues, they tend to link AI with lazy people, even though I want to believe that it can really enhance several traits and get rid of tedious tasks work-wise.
Yeah, so I think it depends, right? So if you're there's a lot of people that are using AIs to write reports, to try to do their work, which is okay. That's smart, right? This is a new tool, and you should, use new tools appropriately. I think there's a lot of abuse. I think the students of the world are abusing this dramatically. Although I think what's interesting though, the teachers are changing. I've got a young daughter, so I'm watching this from the sidelines, and the teachers are changing the types of assignments they give now, and for the better. I think it's forcing the teachers to up their game, and create assignments where the kids can't use AI to get the answer. Using AI to get part of the answer, fair game. But there's assignments along the lines of, use an AI to write a report to do this, then analyze what the AI did and come up with 3 things that got wrong. Those sorts of things. That's a pretty good assignment. For age groups and stuff like that. So anyways, yeah. So some people are using the AIs, to be lazy, to do it. Why not? And but at the same time, there's a danger, right? So you can use AI to help you write part of a report or write some source code, perhaps, but you darn well better check what it's writing, because here's a big secret that people don't like to talk about. Generative AIs, the GPT, like ChatGPT 3 and DAL, or 3 or 4, whatever the number is now, 4, I guess, and DALI and Midjourney and all these things, all the generative transformer technology stuff. All they do is make stuff up. They make things up, period. End of discussion on that one, by the way. It's not real. It's made up crap. It's like talking to a marketing person, right? So, and you can see this for yourself. So in ChatGPT, you can type in your prompt and it spews out an answer. And then there's I can't remember exactly what it is, but it's like, they give me a different answer button, right? Do it again. And then it gives you a new different answer. And you can hit it again and you get a new answer, and it's different. And a new answer, a new answer, a new answer, different. Because it's making it up. DALI is, which I use a lot. All my pretty pictures were from DALI. It's very clear it's making stuff up because it gives you 4 answers, right? You type in a prompt and here's 4 pictures. And then you can choose one, and then give me 4 more that sort of look like this, and you get derivations and so on. Or you can just hit the button again and it spews, and with the same prompt, and it spews out 4 very different pictures again. And you can do this over and over and over and over, and you'll never get the same picture twice because it's making it up. It's making crap up. And so, anyways, the implication is if you ask these systems to make, here's a prompt to make crap up for me, and then you type it in and you just copy and paste it or do whatever you do, you're at risk on that one, right? So, particularly with what's coming out of ChatGPT. So you darn well better be, reading and updating, and you might want to use it to start your report, but you certainly don't want to use it verbatim. Same thing with source code. There's great potential for all this Copilot technology. It's been in place for years, by the way. Great potential there, but you want to use that for like 10 lines of code. You don't want to write, it's like going to a program and say, bang out 100 lines of code for me. God help you if you do that, right? It's like write a what you really want to do with a code, or write a function that does this, blah 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 blah, right? And come up with 5 lines of tight code and then test it well. That's what you want from this Copilot function, or from Chat GPT. It can generate Python code and Java code, probably a big pile of stuff. But it's making stuff up. Good luck. At least with source code, you could test it if you've got those skills. But I certainly wouldn't trust any. And then you've got all the copyright issues as well. It's making stuff up by piecing things together that it's may or may not have stolen. Because these tech companies, they haven't been all that respectful of the copyright laws. They're going to learn the hard way. I think they're going to get hammered on a few court cases. But you're at total risk when you use the output of these things. So it is a bit lazy. But if they're talking about AI, their colleagues that are teaching AI, that would be so wrong. I'm astounded by the quality of the people in the AI field and their ability, or how at least they're trying to keep up. The quality of the people in that field is incredible. But if you're just talking normal people that are fooling around using ChatGPT to write the reports, that'll catch up to them.
Well, thanks, Scott. That's all from question answer sessions. It was great presentation and great insights. Thank you very much for getting time for PM Management chapter members and audience. Thanks a lot, and sorry for delay. It was a technical glitch, but we made it. Thank you. Cheers. And that's end of today's session. See you.
Good afternoon, everybody.
Thank you, and have a good night.
Thank you.
That's different. That's something that we are like so much.